Good day, everyone, and welcome to our report, which is all about the fire protective systems and standards. Lalaine W. Gas, and together with my co-reporters, Jessa May Entroliso and Llanie Yin Aguilar, hopes that you enjoy and learn from our presentation. Any interior building element designed to protect and evacuate the building population in emergencies, including fires and earthquakes, and less critical events such as power failures, is what we call the fire and life safety systems. Now, fire protection and life safety systems includes the building exit systems, the fire alarm systems, and fire suppression systems. Fire protection involves the installation and use of structural and operational systems to minimize the impact of fire on people and property. Now let's talk about the fire alarm system. Fire alarm system is designed to alert us to an emergency so that we can take action to protect ourselves, the staff, and the general public. Now, fire alarm systems are found in various places, such as in offices, factories, and the public buildings. A fire alarm system is installed for protection of life, property, and mission, and there are various functions that a fire alarm system must perform, and this includes to detect the presence of fire, notify the occupants, notify the fire department, usually through a central station connection, and operate other safety functions, like release magnetically held open smoke doors. Now, some may wonder, how does a fire alarm system even works? Now, we must remember that there is what we call the fire alarm panel, which is connected to the system's initiating devices through either 2 or 4 wire circuits. This circuitry allows the control panel to monitor the state of its initiating devices, usually by zones, identifying whether the devices are in normal or alarm mode. The control panel shows these readings on its display panel. When a fire starts, the smoke or heat will activate one of the initiating devices, or someone will activate the manual pull station, alerting the fire alarm system to the fire and putting it in alarm mode. In every fire alarm system, there is always what we call the fire alarm control panel, also known as the FACP, which is the system's brain. It receives messages from the initiating devices, also known as the inputs, and performs the following functions. First is turning on notifications. It alerts people in the vicinity that an issue has occurred. Next, we have the elevator recall, which eliminates the possibility of an elevator delivering people to a flame or smoke-filled area. Then we have the HVAC, systems shutdown, and lastly, notifying alarm monitoring center, which will notify emergency services. Then we have the types of fire alarm panels. There is actually two types. First is the addressable panels. Addressable panels monitor all alarm components individually. Each device comes with a distinct separate address, which allows the panel to know their status. Then we have the non-addressable. This type of system puts all initiating devices in zones, meaning users physically have to check each device in that zone to find the one in alarm. Fire alarm systems have actually many components, namely fire alarm control panel, the initiation devices, the pull stations, the smoke detectors, duct detectors, heat detectors, beam detectors, air sampling smoke detectors, water flow switches, the tamper switches, notification devices, the audible devices, strobes, strobes or horns, the dialers or communicators, and lastly, the NAC power supplies. The fire alarm panels continuously monitor and indicate the state of the fire alarm systems. For most systems, there are three possible states, namely the normal, the alarm, and the trouble. When we say normal, it means that all appliances, devices, circuitry, and wirings are functioning correctly and that there are no active alarms. When we say alarm, this status indicates an active alarm. And then we have the trouble. If an open or short wiring develops in the circuits that connect the initiating devices and the fire alarm panel, or if the system's phone line connection isn't working, the system will go into a trouble state, which the control panel will display. Now, let us proceed to the fire sprinkler systems. A fire sprinkler system is an active fire protection method consisting of water supply system providing adequate pressure and flow rate to a water distribution piping system onto which fire sprinklers are connected. How does a fire sprinkler system works? Fire sprinklers include a network of piping filled with water under pressure that are installed behind the walls and ceilings, and individual sprinklers are placed along the piping to protect the areas beneath them. Because the water is always in the piping, fire sprinklers are always on call. If fire breaks out, the air temperature above the fire rises and the sprinkler activates when the air temperature gets high enough. The sprinkler sprays water forcefully over the flames, extinguishing them completely in most cases, or at least controlling the heat and limiting the development of toxic smoke until the fire department arrives. Only the sprinkler nearest the fire activates. We should know that smoke will not activate the sprinklers. Here are the fire alarm system components. First, we have the control valve. It's generally locked in an open position if fire sprinklers is not in use. Next, we have the alarm valve. This is a one-way valve that controls the flow of water to the fire sprinkler system. Next is the sprinkler heads. They can be generally seen from the eyes and are exposed to the environment. They are designed to open upon exposure to high temperatures. We have the alarm test valve. This valve facilitates the flow of water in the sprinklers. The motorized bell. The water flow enables this bell, which creates the sounds of the fire alarm. Then we have the pressure switch, which monitors the flow of water in the fire sprinklers after the alarm valve activates. The flow switch enable and monitor the flow of water in different parts of the fire sprinkler system. The pressure gauge measure the pressure across the fire sprinklers systems and generally are in two number. The jacking pump stimulates the flow of water from the water supply through the fire system. Now let us proceed to the fire door. Fire doors are an integral part of a building's passive fireproofing plan. They are used for fire compartmentation. When we say compartmentation, it is a process that places physical barriers in strategic areas around a building to slow the spread of flames and smoke in the event of a fire. Fire doors can be made with a combination of timber, steel, gypsum, and aluminum. They can also have windows, which are made from borosilicate or ceramic glass, both of which offers a higher fire resistance than standard glass and may contain an anti-shattering wire mesh. To enhance their fire-stopping abilities, the fire doors are flushed with the frame. Any gaps are filled with silicone-based fire-resistant sealant, and these are often accompanied by an intumescent strip attached at the base of the door, which expands when exposed to heat to prevent smoke from seeping underneath. Now, fire doors are commonly designed to include a closing mechanism, usually fitted at the top of a door, and these spring-loaded or hydraulic mechanisms force the door closed, preventing fire and smoke from passing from one area to another. It is worth mentioning that whilst many doors may contain some or all of these features, they may not necessarily be fire doors. To be called a fire door, a design must be certified by a manufacturer. Fire doors certification is awarded once a door has passed various tests at an approved center, including a fire and stress simulation. You can tell which doors have been certified by a label attached to their top edge, which states the manufacturers, the date of manufacture, and the designated fire rating. So these here are the examples of the labels that are found in fire doors. Now there are different grades of fire door, and each one provides a different level of protection. The grades are separated by how long they can withstand fire. The main ones are FD30, which is 30 minutes, the FD60, which is 60 minutes, the FD90 has 90 minutes, and the FD120, which is 120 minutes. The main aspect that differentiates the grades is the certified core thickness of the doors. This is the core material of the door over which there can often be a static layer of different materials. Now let us proceed to the next topic, which is the fire extinguisher. Fire extinguisher are portable or movable apparatus used to put out a small fire by directing onto it a substance that cools the burning material, or deprives the flame of oxygen, or interferes with the chemical reactions occurring in the flame. Now the fire extinguisher have many types and color codes. There are 6 main fire extinguisher types, which are the water, the foam, the CO2 or the carbon dioxide, the powder, the water mist, and the wet chemical. Now for the water, this has the Class A fires. It is for the Class A fires, which is the solid combustibles. Some water extinguishers are safe on electrical equipment if dielectrically tested. For the foam, which is the AFF foam, this is for the Class A and B, which is the flammable liquids, safe on electrical equipment if dielectrically tested. And the carbon dioxide fire extinguisher is for the Class B and the electrical equipment. The ABC powder is for the Class A, B, and C, which is flammable gases, and some electrical equipments. So the deionized water mist is for the Class A, B, and C fires and electrical equipments. And lastly, we have the wet chemical, which is for Class F fires, which is deep fat and sometimes Class A fires. And here we have the color codes for fire extinguishers. First, we have the red, which is for the water. For the blue label is for the dry powder. The cream-colored label is for the foam. The black one is for the carbon dioxide. And lastly, the green one is for the vaporizing liquids. Now, how do fire extinguishers work? So inside a fire extinguisher is quite like a giant aerosol can, often with two different substances inside. Now one of them is a solid, liquid, or gas substance for fighting the fire. The other one is called a propellant and is a pressurized chemical that makes the fire fighting substance come out when we press the extinguisher handle. Now next time you see a fire extinguisher, take a good look. Have you noticed that fire extinguishers are always really strong and steel canisters? That's because the propellant is stored inside at high pressure. Strong canisters are needed to stop the extinguishers from exploding. Now our next topic is all about the special hazard fire protection systems. We can identify or define special hazards as, but not limited to, any area containing equipment or processes of exceptionally high value, any area containing a unique or irreplaceable assets, such as the museums, the archives, art galleries, and record storage. And lastly, any area or process where the revenue produced or its function is of greater value than the equipment itself. Now, what are special hazard fire protection systems? It is designed to quickly detect an incipient fire or heat condition, designed to suppress fires when sprinklers are not appropriate as the first and only means of fire protection, designed to protect people, designed to mitigate business interruption, designed to limit the loss of assets, information, and revenue, and lastly, it requires uniquely trained and qualified personnel to design, install, service, repair, and maintain this system. Now, under the Special Hazard Fire Protection System is what we call the Dry Chemical Fire Suppression System. Now, a dry chemical fire suppression system is a type of fire protection system that makes use of a dry chemical powder to extinguish a fire. Most dry chemical fire suppression systems makes use of a large tank that is filled with the dry chemical powder and then pressurized. That dry chemical powder works to smother and extinguish the fire as soon as possible. Now, there are two main chemicals employed by a dry chemical fire suppression systems, namely the sodium bicarbonate and the monoammonium phosphate. The sodium bicarbonate can handle all Class B fires and some Class C fires, while monoammonium phosphate is an all-purpose solution used for fires in classes A, B, and C. Now, what are the applications of the dry chemical fire suppression system? Well, they are especially useful in environments where water is inaccessible or where a fire sprinkler system is not preferred. Since they are non-conductive, they can also be utilized to suppress fires on flammable liquid, fires that involve live electrical equipment. So what are the advantages and the disadvantages of such a dry chemical fire suppression system? So the advantages includes that they are extremely reliable. These systems are both accessible and efficient to use because they are rechargeable. Now they are great for areas where a fire sprinkler system is not ideal. The dry chemical fire suppression systems can be actuated either electrically or mechanically, and that they have a significant reduction in maintenance costs for these systems over other options. Now, for the disadvantages, includes that the system must be recharged after it is activated in order for the system to work again. And because these systems pump out a lot of agent to extinguish the fire, extensive cleanup is required after each use. You'll need to follow proper dry chemical cleanup procedure to get your facility back in working order. Now, also under the Special Hazard Fire Protection System is what we call the Gaseous Fire Suppression System. So, gaseous fire suppression, or also known as the clean agent fire suppressions, are terms used to describe gases used to extinguish fires. Now, inert the atmosphere, reducing oxygen levels to a level that will no longer sustain combustion, react chemically with fire-absorbing heat, and causing the chain reaction of combustion to break down. Now, clean agent fire extinguishing systems are typically used to protect three-dimensional enclosures containing high-value assets that are vital for business continuity, and assets that cannot be protected by traditional sprinkler systems due to potential form of water damage. And lastly, under the Special Fire Hazard Protection System is the Foam Fire Suppression System. A foam fire suppression system is a type of wet sprinkler system that combines both water and foaming agent for large-scale fire extinguishment. This water-based fire sprinkler suppression system can extinguish extensive fires in mere seconds with incredible efficiency. Now, how do foam suppression systems put out fires? So, foam suppression systems extinguish fire by separating the fuel from the oxygen. Now, these systems are used to cool the fire and coat the fuel that the fire is consuming to prevent contact with oxygen and reduce combustionability. This extinguishing agent, which is the foam, smothers or blankets the surface of the fuel. The water content of the foam then cools the fuel and the area of foam covering the fuel to prevent reignition via flammable variables.
Fire protection systems. Fire protection systems are systems that are standard building features that help to control the amount of damage that can occur to a building and protect its occupants in the event of a fire. Classification 1. Active fire protection systems. These systems work to contain the spread of the fire with the action of dispersing water or other compounds and alerting occupants to its presence. 2. Passive fire systems. These systems contain fires without taking action by utilizing building compartmentalization through the use of fire-resistant walls, doors, and coatings. Automatic fire sprinkler system. Automatic fire sprinklers work to spread a continuous flow of water over the fire and dampening it enough to be fully put out. Classification 1. Wet pipe sprinkler systems. These systems are filled with water at all times, allowing for quick fire suppressions. These are the most common types of sprinkler and are both cost efficient and low maintenance. Dry sprinkler systems. These systems use pressurized air in the pipe which exits before water escapes. Third, pre-action sprinkler systems. These systems are filled with air and water which passes through if the smoke alarm or detector goes off. 4. Deluge sprinkler systems. These systems feature open nozzles and are common to industrial parks as they respond to hazards including flammable liquids spilling across a floor. Fire extinguishing systems. Fire extinguishing systems functions by quickly extinguishing a developing fire and alerting occupants before extensive damage occurs by filling the protected area with a gas or chemical extinguishing agent. These are classified into two types. First is the engineered systems, which works by flooding an entire room with gases that suppress fires without harming humans or equipment. 2. Pre-engineered systems. These systems do not flood an entire room. Instead, they are designed to protect smaller enclosures or special hazards. Standpipe system. Standpipe system is a series of pipes which connect a water supply to hose connections. They are designed to provide a pre-piped water system for building occupants or the fire department. It is classified into three classes, mainly the Class 1, Class 2, Class 3. So these are the parts of a standpipe system. First is the riser clamp, the flexible coupling, the standpipe hose connection, and the upper flexible coupling. Classification. Class 1. A Class 1 standpipe system shall provide a 2.5-inch hose connection for use primarily by trained personnel or by the fire department during initial response. This type of class has no hose attached. 2. Class 2. A Class 2 standpipe system shall provide 1.5-inch hose stations to supply water for use primarily by trained personnel or by the fire department during initial response. These are typically found in cabinets with 100 feet of hose. Third, Class 3. A Class 3 standpipe system shall provide 1.5-inch hose stations to supply water for use by trained personnel and a 2.5-inch hose connection to supply a larger volume of water for use by fire departments and those trained in heavy fire streams. Portable fire extinguisher. A portable fire extinguisher functions by releasing an extinguishing agent intended to cool the fuel, remove or displace the oxygen, or stop the chemical reaction. Classification. First, water extinguishers. Water extinguishers are filled about 2/3 with water and then pressurized with air. When used for Class A fires, these extinguishers remove the heat from the burning materials. So these are the parts of a water extinguisher. First, we have the handles, the safety pin, the pressure gauge, the hose, the pressurized air cartridge, the siphon tube, and the water. Number 2. Carbon dioxide. Carbon dioxide extinguishers extinguishes fire primarily by excluding oxygen from the combustion region, although there is some cooling effect. Carbon dioxide extinguishers are filled with non-flammable carbon dioxide gas under extreme pressure. You can recognize a carbon dioxide extinguisher by its hard horn and lack of pressure gauge. The pressure in the cylinder is so great that when you use one of these extinguishers, bits of dry ice may shoot out the horn. 3. Dry chemical agents. Dry chemical fire extinguishers extinguish the fire primarily by interrupting the chemical reaction of the fire triangle. The most widely used type of fire extinguisher is the multi-purpose dry chemical that is effective on Class A, B, and C fires. Fire alarm and detection systems. Fire alarm and detection systems are designed to discover fires early in their development when time will still be available for the safe evacuation of occupants. Basic components. 1. Fire alarm initiating devices. These devices activate the system when a fire occurs. Under this is the manual initiating devices. These devices include pull stations, break glass stations, or buttons that need to be manually activated by someone in the building when they identify a fire. Manual initiating devices need to be well marked and accessible to make it easy to identify and use. Automatic initiating devices. These devices trigger the fire alarm system automatically when a fire happens. These devices include heat, flame, and smoke detection. When heat, flames, or smoke is detected, the devices send a signal to a central control panel that activates the system. 2. Fire notification devices. These devices notify building occupants when a fire is detected. Examples of these are the bells, the strobes, horns, and the chimes. 3. Primary power supply. The primary power supply is typically 120 or 240 volt AC power sources. 4. Backup power supply. The backup power supply includes 6 or 12 volt batteries to keep the system running when a power failure happens.
So for our next topic, it is all about the emergency alarm system. So what do we mean by an emergency alarm system? So an emergency alarm system warns people when there is a smoke, a fire, a carbon monoxide, or any other fire-related emergencies that are being detected. So these alarms may automatically be censored by the smoke detectors, the heat indicators or detectors, or may also be activated by manually pulling the trigger, so the manual fire alarm activation that are often seen in schools. So these alarms can be either motorized bells or wall-mounted sounders or horns. So next. So this is an example of how a smoke or a fire is being detected. So from this smoke, a sensor will detect, or either a manually pulling alarm will be operated, then a sound will then signal or ring notifying that it is time for evacuation. So this in this slide, the fire system alarm may be incorporated by a remote signal. This is a remote signal, and then alert the fire brigade through this central station. So from this alarm, this will go to the central station, and the central station will then alert the fire brigade. So the brain of the system is this fire alarm control panel. So this is the central hub for all detector signals to be wired to provide a status for indication of the users. So next is this unit, the stimulator. This unit, the whole unit, can also be a setup to stimulate for an alarm that is used in fire routine and evacuation drills, the ones we do on school. And so to alert that all the staff knows what action to take in the event of a real life or if there is a real fire. So this is the ones that we pull the trigger when there are fire alarm drills so that it will ring, so that we can also know what are the things to be done when there is a actual fire. So this is an example of a sensors. These three are example of a sensors that wherein there is a smoke here, the smoke will detect. But this is also a different one. This is the sensor that will directly detect to this control panel. But we can also do a manually pulling trigger, the ones that I've said that we've seen on school. So there are 5 types of alarms. The first one is the automatic fire alarm system. The second one is conventional fire alarm system, addressable fire alarm system, and one-stage and two-stage fire alarm system. So let's proceed. The next one is the smoke control system. So a smoke control system is this is design, or the design is the design objective is for a smoke control that can vary depending on the situation which is being used. So for an example, a hospital might have a design objective containing a smoke to the certain zone of the fire of origin. Have you seen the movie Skyscraper, where this floor is only on fire but the other floors are not? So this is how a smoke control system is being organized. So this is a system that controls the movement of the air and smoke in the building so that dili siya spread sa other floors. So it can be made up of multiple different components and several use methods to achieve its design objective, which is typically to maintain a tenable environment for long enough occupants to egress the building. Of course, if na ay lugar, certain area nga na ay fire, syempre dili ta moagi dito. So mangita-itag pamaagi kung asa ta mugawas. That's why we have our fire exits. So there are two ways to establish a smoke control. The first one is the smoke management system, which maintains tenable environments in the means of egress from large volume spaces or prevent the movement of smoke into surrounding spaces. So the examples of this are, the first one is the mechanical smoke exhaust, which is or which requires a new way for make-up air to be injected into large spaces. So otherwise, the pressure could build up into the building to be so high that it will start in negative to affect the other building system. It is also important to make sure that the make-up air intake is clean, fresh air and not located adjacent to where the smoke can be exhausted. And then the second one is the natural smoke ventilation. So a natural smoke ventilation is by taking advantage of the buoyancy of the smoke, because the mechanical smoke exhaust use propellers to move the smoke in and smoke and air outside of the building. But typically the goal of this system is to keep the smoke layer interface above a high occupiable level that is open to the large spaces for a certain period of time. So the other one, the way to establish smoke control is through a smoke containment system. Do not be confused, because the other one is smoke management and the other one is containment system. So a containment system keeps the smoke from entering specific areas using pressurized or pressurization, and are commonly found in enclosed stairwells. So there are four types of this, and the first one is the stairwell pressurization. So this is intended to prevent smoke leaking through the closed doors by injecting clean air into the stairways. So the intent is to have a high pressure in the stairwell and reducing pressure accommodation area to facilitate pedestrian escape route and fire fighting access. The second one is the smoke control or the zone smoke control. So this is a system that divides the building into separate smoke control areas by creating a pressure in the differential levels within these zones, so the spreading of the smoke so that the spreading of the smoke is inhibited. So this system is actually creating a pressure, the one we call sandwich, para maipit siya around the zone where the fire is present. Next is elevator pressurization. So this is made by engineers achieving an elevator pressurization using a system of ducts and powerful fans. So these fans generate positive differential pressure smoke that cannot enter the hostway to spread freely from one floor to another. And the last one is the vestibule pressurization. So this is a direct that there are these direct pressurized vestibules in the staircases. So it is an effective method to prevent the smoke infiltration into the staircase, thereby assuring smoke-free means of escape to the building occupants and means the access of fire brigade. So this is particularly in high-rise building, itong tag-as na kayo. So next topic is all about smoke, heat, and vents, because if there is a smoke, there will also be a ventilator or gawasanan sa smoke para dili maghuot ang smoke sa isa ka building. So this heat and smoke vents are installed in the building as an active fire protection measure. These openings in the roof, this one is an example, are intended intended to vent the heat and smoke developed by a fire inside the building. These are also known as gravity vents. So what is the role of the smoke vent? Unsa man gyud iyang pulos diya sa taas kana mga chimney na magas-gas lang. So the role of the smoke vent is the role of a smoke vent is of course to save lives by reducing the smoke inhalation and keeping the fire escape routes free from smoke. Of course, dili ta pwede mag-inhale og smoke kay masuffocate ta or lain ang iyang effect sa atong lawas. Muna dili ta kagawas if na emergency. Next is how firefighters do their jobs by improving visibility and revealing the source of the smoke. Of course, kung naay oxygen, musulod, mugawas ang fire, unya dili siya maghuot lang sa isang building. And the next is to prevent the damage that could lead to building collapse. Kay sunog naman kay ang sulod, possible nga mag-collapse ang isa ka building kay bali ang isa ka floor kay murag na burnt na siya. So muna ang help sa smoke vent. So this is an example of a smoke vent. So in their most basic form, smoke vents are opening such as window or skylight that offers an escape for smoke and hot air para makagawa sa atong kwan. So if this smoke niya sa ubos, so wala magyud na smoke niya sa ubos na ara man na sa taas. So kaning vent, this vent muna siya ang magpatabang magpagawas og mga smoke para dili nato ma-inhale. So how smoke vents work? Because this smoke vent, this is an example of a AOV. So what is an AOV? AOV is an air opening vent. Air opening vent are smoke vents that automatically breaks out when there is fire. This is a sensor, of course. So when the sensor detects fire or smoke in the building, they open automatically the roof vent to provide the para ang smoke mugawas sa vent. So, what to look for in a smoke ventilation system? So, of course, it is important to ensure that your smoke vents are completely requisite with all the building requirements or regulations. Make sure that you are up to date and compliant with all legal requirements for your building type. Na binagdag ko kayo may construct na building, so kailangan yun og roof vent para nagawasan na sa smoke. So these are examples of vent types. Number 1 is the automatically mechanical type vent. So these automatic vents are installed with curbs to protect them from the weather and make them more visible to people when walking on roof. Kabantay mo anan ka na sa taas na abi na tong usay nakabutang diha nga mga warehouse. Dili na siya warehouse. Some of them are vent types nga i-open na ay mag-open sa taas para magawas ang smoke. So, usually the hatches are spring-loaded or released upon melting at temperature in the rated fusible leak. So, next, another type of vent is the dropout vent. So, dropout vent are the domes which functions as skylight, are made of plastic that will melt and drop out the prescribed temperature. No fusible link is involved, dili pareha atong sa isa. So the vent can be operated manually from inside the building or from the roof. Kapantay mo nang naiuban per sa SM Uptown nga murag clear iya ha. Dili na siya roof but that is somewhat a dropout type vent. So of course kung naay smoke sometimes ang reason is explosion. So, how can we control explosions? So, controlling fire explosion and risk. So, this is an example of an explosion that we often see kana sa mga gas stations, kana sa mga mubukto nga gasol sa balay. So, a person conducting a business or undertaking is called BSCE must prevent the possibility of fire explosion from an ignition of flammable sources associated with a hazardous atmosphere. So of course, dili mag-ignite or dili mag-explode ang isa ka butang kung wala siya source of ignition. So of course, kung kung na-explosion, may itatawag safe lugar, safe na tuan, para ma-protect. So according to Section 355 of the Work Health and Safety Regulations 2011 edition, requires a specific control for prevention of the fire and explosion associated with hazardous chemicals. And according to Section 52 of the Work Health and Safety Regulation, requires a PCBU to manage risk, health, and safety associated with an ignition source in the hazard atmosphere. With respect to flammable substances, a hazardous atmosphere is an atmosphere where the concentration of flammable gas, vapor, mist, or fumes. So, hazardous area. Hazardous area is an area where it involves mga flammable atmospheres, or it is expected to be present and requires special precautions for the construction, installation, and use of equipment. Of course, naagi na hazardous area like laboratories, gas stations, even in our house, naagi hazardous area. So examples of hazardous area. Number 1, the gas station. Of course, kay naa day fuel, basin dili kabantay mo na mubutang diya nga no smoking or turn off vehicle, kay basin ka na ang possible nga mag-ignite sa lugar. Next is laboratories. Of course, bisag asa ka nga laboratory, kailangan ka mag-wear protective materials, PPE, gloves, goggles, para dili ka magka-infection or dili magka-trigger imong ang mga gamit sa sulod sa laboratories. Next is warehouse. Of course, tambakan ang warehouse. So, possible na ay mga tambak-tambak niya. And lastly, our home. Our home is diha taga-spend of day, diha taga-kaon, diha taga-katulog. So, we must take care of our home. Kaya mayon mo nga, dili man na siya ka na flammable. No, our home is very flammable. Labi na pag ni mga bata magdula-dulaw mga matches. Inana. So, potential ignition sources can be identified, either eliminated or controlled to prevent a fire or explosion. So, an ignition source provides the source of energy to ignite a flammable atmosphere. Of course, example, kay lighter, labi na sa gas station, bawal magdala og lighter, bawal manigarilyo. So, examples of potential ignition sources are smoking, matches and lighters, electrical system, labi ng mga mag-short circuit sa itong balay-balay, kan mga tap-tap lang na itong wire. Welding, of course, kaiyang spark. Exhaust pipe, yes, maka-trigger ang exhaust pipe. And of course, our kitchenwares, kay na dito tanan ang mga luto-luto. So, maka-trigger na siya, labi na kung naa ka sa balay. Kanya, dili pa kayo kabluto, dili ka kabalo mag-on sa gas stove, inana. So, to prevent, here are the risk control measures to be attained. First is identifying and managing the hazardous areas. Second is control emissions of flammable vapors, gases, and mist. See below, that is not included. So the use of ventilation systems to control vapors during both normal and abnormal conditions. Of course, kanang kabantay mo sa inyong kusina usahay nga lain og baho-baho og gas. So dili ka mag-on og bisag unsa, dili ka mag-on og light match. So dapat imong buhatan is mag-abre ka og vent or exhaust para mo gawas to ang baho ay din ka mag-on. So next is minimized exposed surface areas. Of course kanang mga liquid kanang mga yabog gikan lower ka nagtrabaho unya ni mga yabog mga flammable, of course pangitaton mo pamaagi nga matambakan to siya. And avoidance of splash filling. Yes. Another one is minimizing the temperature liquid being processed or transferred. Naay uban liquid nga kailangan og temperature lang nga inanira siya okay. Dili nimo siya pwede exceed, dili nimo siya pwede below because that will also cause fire. And provide ventilation. Example, mechanical extraction for all source of vapor and vent to a safe area. Ensuring electrical equipment is efficiently maintained, where poorly maintained electrical equipment can present a significant risk. That is the top work. Itong mga DIY nato, kahiling mo ito mag-DIY nga. Kani ako ning itap ang wire dani kay para musiga inana. Basin di mag-short circuit, so mo na maka-trigger sa fire. So of course, fire, dili mawala ang fire pumps. Fire pumps kausanan sa tubig. So these fire pumps are critically component of many sprinkler system, of course. Fire pumps intakes are connected to a underground public water supply piping or a tank or reservoir to provide a water flow at a higher pressure to the sprinkler systems, risers, and hose standpipes. So why are these fire pumps needed? First, fire pumps are required when local municipal water cannot provide adequate pressure to meet the hydraulic demands of the fire sprinkler system. And fire pumps are also needed if the sprinkler system water provided from a water storage tank. How do these fire pumps work? Fire pumps are powered by a electric motor or diesel engine. It means pwede ra siya nga ipansak or pwede siya nga tubililan lang siya para mugana. Murag generator inana. If the local building code requires power independent of the local electric power grid, because sometimes muwat anong kurente sa lugar na paggamit ng fire pumps, so that is diya musulod ang diesel engines. So the sprinkler system pressure drops significantly when one or more fire sprinklers are activated, or alternatively when the other firefighting connections are open, causing a pressure to drop. So there are types of fire pump used in fire service. The first one is the horizontal split type case, vertical split case, vertical inline, vertical turbine, and the end suction. So this jockey pump is a small pump that connects the fire sprinkler system in a parallel fire pump. It maintains a pressure in the fire protection piping system to an artificially high level so that the sprinkler will operate. So fire pump installations and retrofits are governed by the National Fire Protection Association. So dili mahitabo nga gidiretso lang nagpalit ni inani. Dili ka pwede inana kay muagi pa na siya sa National Fire Protection Association. So there are types of fire pumps. First one is the positive displacement pumps. So these are characterized by a method of producing a flow by capturing a specific volume of water per pump revolution and pushing it through the discharge line. So the other one is the centrifugal pumps. So these are common fire pumps which are used in most of our systems. So with this, the pressure is developed principally by the action of the centrifugal force or the spinning. Water in centrifugal pumps enters the suction inlet and passes through the center of the impeller. So an example of this centrifugal is the horizontal split case pump. So this horizontal split case pump allows the flow that splits and enters the impeller to the opposite side of the pumping house. As the name implies, this pump is installed with a split casing that can be opened for pump maintenance access, and it is connected by the driver to a horizontal shaft. Next one is the vertical turbine pump. A vertical turbine pump is only a pump that allows the NFPA standard installation of the stationary pumps for fire protection that can start with a negative suction pressure or take water to uplift a condition such as from a below down grade such as the river or the subgrade tank. Next is the inline pump. Inline pump is where the space where it is limited. This can be driven by both a vertical or horizontal shaft. So vertical shaft, which are most common, have the driver located above the pump. So typically one of the less expensive units and take an at least amount of space, but there are also one of the most expensive to repair. Pinakabarato siya paliton, pero pinakamahal siya ayuhon. So, dapat ampingan yun. So, end suction pump. This is a pump that has a discharge outlet perpendicular to the suction inlet. Compared to the horizontal split case fire pumps, they are more compact and require less installation space in a fire pump room where available space is concerned. And lastly, the multi-stage, multi-port. So these pumps can be used in a single driven that can either be electric motor or a diesel engine that connects to the pump with a multiple impeller in a series in a single case driven by a horizontal shaft. So of course, kaning mga fire protection system would not be possible without the Bureau of Fire Protection of the Philippines. So this Bureau of Fire Protection, or in Filipino we call it kawanihan ng pagtatanggol sa sunog, is a government fire service in the Philippines. So this is under the jurisdiction of the Department of Interior and Local Government, or the DILG. So what are the primary functions of the Bureau of Fire Protection? First, it prevents and suppression of all destructive fires, enforcement of the revised implementing rules of the RIRR of the Republic Act 9514, otherwise known as the Fire Code of the Philippines. Investigate cause of fire if necessary, file a complaint to the city or provincial prosecutor relating to the case. Dili ta magbot-bot og file nga gikan mo sa inani ang fire. No, the BFP is there to solve the case kung dili ta kabalo asa nag-trigger gikan ang fire. Next is, in an event of national emergency, they will assist the military and the orders of the President of the Philippines, and establish at least one fire station with all personnel and equipment per municipality and provincial capital. So, kada barangay, kada mulungsod na agyoy fire station, dili na pwede mawala because that is a requirement on our municipal and provincial capital. So, the BFP. The Bureau of Fire Protection was formed on January 29, 1991 through a law named Republic Act 6976, created by the present Interior Department and placing the fire services under its control. Of course, our President Rodrigo Duterte signed the Republic Act 11589, or the BFP Modernization Act, on September 10, 2021, mandating the implementation of a 10-year program to modernize the BFP. And of course, a BFP or an isa ka organization will not be possible without the committees or the leadership. So these are the leadership under the BFP. Our President, Chief, or the Chief of Commander-in-Chief is President Rodrigo Roa Duterte. Secretary of Interior and Local Government, Secretary Eduardo M. Año. Undersecretary for Public Safety, Nestor F. Kinsay Jr. Chief of the Bureau of Fire Protection, Fire Director Louis S. Puracan. Deputy Chief for Administration, Superintendent Ruel Jeremy G. Diaz. Deputy Chief for Administration, Ruel Jeremy G. Diaz. Deputy Chief for Operations, Wilberto Rico Neil A. Kwan Chu. And the Chief of the Bureau of Fire Protection Directorial Staff, Jesus P. Fernandez. So that is all for the fire protective system and standards. I hope you all understand what is it all about, because kita tanan maka-experience of fire, or kung dili man kita tanan, at least kita makatabang sa atong lugar para unsaon pag-prevent, unsaon pag-minimize sa mga cause sa fires. So these are the examples that we have presented to you with my mates. I hope you all understand, and thank you for listening. That's all. God bless.